So good morning, friends. This is Durga from IT University. As you guys are aware, especially those who are on YouTube, this is the primarily backup session for my live audience. So in case if we could not answer your questions, please understand that this is primarily a live training going on, and uh, I'm streaming these videos to YouTube just for their backup. But you guys can learn, and if you have any questions, you can write those on discuss.itversity.com. That being said, let us get started. We are in the middle of Spark. Today also there might be some hiccups because I didn't get the connector, Ethernet connector for my Mac. Hence, there can be some hiccups in between, but we will keep a close eye on that. And if there are any issues, we will wait until that issue is resolved. Okay, so that being said, the course which we are talking about is Apache Spark using Scala. And as of now, we are talking about transformations and actions. We have covered actions in detail. We have covered row-level transformations, and then we have covered aggregations. Now comes the next set of important transformations called join operations or joining datasets. Okay, so and even though it's not a functional requirement as such, because as part of the business requirement, they will not tell, please join the datasets. They will only tell, I want to see these metrics. And as part of that metrics, you might have to do aggregations, you have to do data cleansing, you have to filter the data, etc. One of the technical operation which you will be performing is joining the datasets. And why we need to join the datasets? Typically, our data models will be normalized. So if you go back to setup datasets page, and if you closely observe this retail DB database, we have 6 tables, and all these tables are normalized. Even if you think about transactional data, which is orders, the data is actually stored in orders and order items. Okay. And in case if you want to, so what orders have? Orders have the order level attributes. So let me connect to the lab and also launch this Spark shell. Or let me connect to the MySQL so that we can actually get the metadata of the tables. Q retail underscore DBA minus H nn01.itversity.com. ITversity is the password. Okay, and then if you type show databases, you will see 3 databases: retail DB, retail export, and retail import. You can ignore information schema. These are the databases to which retail underscore DBA user have access to. And if you go to retail DB here, you can see orders and order items. And if you see the relationship between orders and order items, it's one-to-many relationship. At orders level, you have this circle and dash below that. And towards the order items, you have the fork symbol. Fork means many. So the relationship between orders to order items is many, one-to-many. So for example, if you do this, select star from orders, where order ID equal to 2. Order ID is the primary key in orders table. There is only one record in this. And then if you describe order items, you can see multiple fields, and one of the field is order item order ID. It is the foreign key to orders. So here, if I say select star from order items, where order item order ID equal to 2, you can see there are 3 order items in this single order, which is order ID 2. So what does that mean? If you go to Amazon.com or Flipkart in India, you go, you check out multiple products into the market. Sorry, you add multiple products into the cart, and then you will check out the entire cart in one shot. So when you place, it's a one order. You are placing one order, which will have multiple items in it. So this orders table will have all the order level details, such as when the order is placed and who placed the order and the status of the order. These are the order level attributes. But an order can contain multiple items. Those things go to the order items. Okay. And what does this contain? It has foreign key to order ID in orders and the product ID. So for each item in order, there will be a product ID associated with it. You have to buy some product or the other. Okay, so there will be order item product ID. And sometimes if you try to buy soda cans or water bottles, typically you will buy multiple of them. Hence the quantity. And then subtotal. Subtotal is nothing but the revenue for that order item, which is nothing but the product price multiplied by the quantity. For example, if you buy 10 water bottles and if each water bottle is 50 cents, order item subtotal will reflect the $5 and order item product price will reflect the 50 cents. So subtotal is nothing but the derived value from quantity and product price. Okay. And for each order item, we will have these details. That's why we have 3 of them. And if I want to compute the revenue of order ID 2, I have to join these 2 tables and add this amount. One minute, okay? I have to join these 2 tables and then get the other details of orders and the revenue. Just to get the revenue per order, you don't need to join. But if I want to get order date and order status, which is very important for a given order, along with the revenue, then we definitely have to join these 2 tables. On top of this thing, if I want to get order order date, order revenue, order status, if I want to get customer details also, such as customer name, address, etc., then I have to join customers tables to customers table to orders. Okay, because the relationship between customers and orders is again one to many. You can see here, for each customer there can be a number of orders. So if I want to get additional details of customers than customer ID, I have to join this as well. So depending upon your requirement, you might have to join multiple tables to get the final metric which is requested by the business. So understanding joins is very, very important. And join is one of the dot, and you should be able to connect with other dots such as filter, aggregations, sorting, etc. So you should be able to develop the applications by connecting all the dots effectively. For today, we'll be focusing on joins, and then we will actually talk about set operations as well. Okay. Now let us see the syntax of so you can see that you can not only join the data, you can also do the co-group, Cartesian, etc. We will see what are they a bit later. First, we'll start with join and we will see the other stuff. And to get the syntax, I will highly recommend to go with always to go with the official documentation. Okay, so Spark programming guide. You can go here. Sorry, we are talking about 1.6.2. You have to refer the correct version of Spark programming guide. Okay, so if you go here, join is also a transformation, and you can see it here. It got stuck. Let's wait for a moment until it is back to normal. Then we'll go ahead. So is it normal for you guys? Yeah, now it is back. Okay. So So make sure you select the appropriate documentation, whatever version you are working on. At least the major version have to match. So we are actually talking about 1.6, so refer to 1.6 only. And what does the explanation say? It says when called on datasets of type kv and kw. So what does this mean? It is nothing but a tuple, and k stands for key and v stands for value from the first dataset. And another tuple, again k stands for key, and which means that this one and this one should functionally mean the same thing. Between orders and order items, if you want to join, the k from orders has to be order id, and the k from orders also has to be order id. Okay, then only you should join, otherwise you should not join. Sometimes there might be multiple numeric fields in the dataset, and people tend to make mistakes by using inappropriate column. You have to do some due diligence here and make sure that whatever column you are using to join means same thing from the both the tables. For example, if I go back here and if I check order items, order item ID is also a numeric field. You can see 2, 3, 4, etc. If I join order items and orders on order item ID and order ID of orders, still you will get the results, but the results will be incorrect. So you have to be very particular about this. While joining, you have to do this additional homework and make sure um, the key in both the tables which you are trying to join have the same business meaning. Okay, then only you should use that field to join. And then once they both join, the results will be another tuple. That's why it starts with circular brackets. The key will be the common key between the two, which is k, and the value is also a tuple. It's a nested tuple within the main tuple. And if you see, this nested tuple have v comma w. What is v? The value from the first table or first dataset, and w is nothing but value from the second dataset. Okay, so this is the output of the join, and you should be able to understand this explanation clearly for all the transformations, not only for this. And then on top of regular join using join, you can also do left outer join, right outer join, full outer join, etc. Okay, so now let's see it in action. So if you look at the data, I'm exiting now and I'm launching the Spark shell. Okay, again, it seems to be stuck on WebEx. Anyway, I'm launching Spark shell. It will take a bit of time. And while it is being launched, let me make the announcement for, okay, uh, it got disconnected. I have to join again. But it got disconnected. Sorry, folks who are on YouTube. My WebEx session got disconnected. So let me. So I'm back, guys. I hope you guys can hear me. And also you should be able to see my screen. Okay, can you guys see my screen? WebEx got abruptly ended, and my YouTube session also got stopped. So I need to start the YouTube session as well. So just bear with me. I think the Wi-Fi got disconnected. That's why both WebEx and YouTube, there was interruptions for both WebEx and YouTube. So this is the quality of ISPs for even corporates in India. Okay. Yeah. Now you should be okay even on YouTube. Please confirm, guys, whoever is on YouTube. Yeah. Okay, meanwhile, the Spark shell is launched, and we can actually, 1 minute, some file, wait a minute. Yeah, now it should be okay. So you can actually see, before actually starting joining the data set, first we need to read the data from HDFS. So I'm creating this path variable. If you are using local file system, you have to give valid local path. If you are using lab, you can use this one. It's a It's in shared location. And then if you just read the data using sc.txt file, and if you look at the preview, if you get the preview of the data, you can see each element in the resultant RDDA after applying sc.txt file is of type string. So you can actually see the data type by just typing this one. Okay, so it is RDD of type string. But if you look at the syntax, what it is expecting, it has to be like this. Okay, so what we are supposed to do from this string, we have to identify the key, and we have to extract the key, and we have to pass it as the first element in the tuple. And then whatever values you want from these orders, let's say I want order date and order status. You can extract those details and add it as value. It could be a string, it could be a tuple, it could be object, it could be anything. Your value can be anything. Okay. So for now, what we are supposed to do, for each of this input record, we have to convert into a tuple. Okay. So let's get order date for now. Let's ignore others and let's get order date for the value. So how can I achieve that? I have to use the map function, map API. And then, so this will actually give the order ID. And if you see rec.split comma on this will give an array. Okay, and the first element is read by using of 0. Rec.split of 0 will give the first element from each record. Because it's a order ID which is of type integer, we should convert it into integer by using toInt. If you don't do that, functionally it might work, but performance wise there can be side effects. So whenever you process the input data, especially from flat files, you have to convert into its original type as early as possible in the life cycle of your project. Okay, that way the operations on the numeric values will be much faster, and compared to operations based on considering that as a string. So you can consider already as a string or a number. Functionally, it will work, but the performance-wise, if you treat it as a number, you will see a lot of benefits over the life cycle of the application and also the particular job. So it is very important to typecast. In some cases, it can also result in functional issues also. For example, if you try to sort the data, sorting numbers as numbers and sorting string numbers as strings will not give the same result. For example, if you sort by as number, uh, um, 10 is greater than 2. If you compare 2 and 10 as numbers, if you compare 2 and 10 as strings, 2 is greater than 10. And if you try to sort, you will get 10 first and 2 next. So there can be functional issues also if you don't typecast to their original formats. So you have to convert your data into their original formats as early as possible. Whether there are functional issues or not, there will be performance issues. So you have to have this in mind all the time. Okay. And then in this case, I want to get the date. Date is second field. Date we can treat it as string for now. So I'm leaving it like that. And then I'm closing the bracket for the tuple and then the map function itself. And then hit enter. Now you can see my orders is of type RDD, which is nothing but a distributed collection, and each element in that RDD is of type tuple. The first element is in the tuple is of type integer, and the second element in the tuple is of type string. And you should make the habit of reviewing the data immediately to make sure everything is working smoothly. Otherwise, if you don't preview immediately, especially at the time of certification and all, you will run into issue when you try to run the job, even if the path is incorrect. What will happen when you actually invoke the action after writing the code? At the time, you will start seeing the issues. As you will write n number of lines of code, it will be very tough for you to troubleshoot the issue. If you make this habit of uh, uh, previewing the data after each and every step, it has two advantages. You will know where the issue is coming from immediately, and the second one is you can do the due diligence and understand what is happening internally. So until you are very comfortable with the technology, it is best practice to preview the data after each and every step to make sure that it is working as expected. Okay, that being said, now let us see the order items. First, if you look at the order, so we need to have two data sets to join. Okay, we already got one data set with order ID as key and order data as value. Okay, and the second thing is we will try to read the order items and we'll try to get the order item subtotal. I will answer that question in a moment, Ashish. Okay, so in this case, I want to get order item subtotal, which is fifth field, which is of type float. So we have to typecast this to float or double. You can use either of them. And then close the brackets for the first one for the tuple and second one for the map function and hit enter. Now let me see this question from Ashish. Yeah, so Venu, I have already responded and I will be demonstrating now. You have to use take order items dot take of 10 dot for each println and hit enter. You can see the data. You got the order item order ID and the order item subtotal. Okay, and if you closely look at the uh, functionality provided as part of the map function, the first one we are trying to read the second element after splitting, which is order item order ID, not order item ID. Okay, now we can join these two. So we can say, okay, I will wait until it is not frozen. Can you see val order join? Familiar, it is only frozen to you. I think for others it is working fine. So if it is still frozen, I think you should probably reconnect. Hello, Somalia. Yeah. Okay, so order join. No, you can. That's what. Whether you split or not, it doesn't matter. All you need is you need to have tuples to join. KV and KW. I have reviewed the syntax. I am not sure whether you are there from the beginning. I have reviewed the syntax. The syntax itself says both the data sets on which you are trying to join has to be tuples. Okay. On a, but the first element should be a similar field, a common field, which is already in this case. Whether you split or not, it depends upon the data you are trying to process. If it is an object, if it is not string, rather if it is an object, you can actually read the field directly from the object. You don't need to apply split. Split is not the main thing here. Main thing is it has to be a tuple. Yeah. Okay, so orders join. Sure. So Pramod is asking to print 10 records from orders also. Take off 10 for each println. and you can see the results. Okay. Now let us try to join this. Val orders join equal to, syntax is very straightforward. Once it is once the tuples are created, you just have to say orders dot join order items. That's it. Nothing else. And hit enter. And orders join. So first let us review the type of the orders join. It is of type RDD. And if you see the element type, it is a tuple. The first one is int, which means the order ID itself. And the second element in the tuple is of type tuple. So it's a nested tuple. The first one is string and second one is float. Because we have orders on the left and order items is passed as parameter, this one will be from orders and this one will be from order items. Okay, so this will be date and this will be order item subtotal. And you can preview the data saying orders join dot take of 10 for each int ln. And you can see the results. Meanwhile, if you go to the task UI, I think 54321 is the number. No, let me click the 53214. 53214. So this is the last take which we have performed on the join. And you see it has created 3 stages. The first stage we can actually check by clicking on this. Actually reads the data from orders. Okay. As part of the second stage, the tasks which are created actually reads the data from order items, and then it also performs map. Okay. And then the third stage is actually performing the join, taking the data from both stages. So this results in shuffle. That's why if you see, okay, even though it is not explicitly saying here, internally it actually shuffles. Okay, there will be shuffling happening within the between fourth, fifth, and sixth before sixth stage. That's why you can see the shuffle details here. Okay, so definitely when you join, it actually perform multiple operations internally. First, it will co-group, and then it will actually apply implicit map functionality to filter out unnecessary data which you are not interested in. That's why the final output is map partitions RDD, even though it is actually creating something called co-grouped RDD to begin with. You don't need to get into those internals, but as long as you understand that when you try to join 2 data sets, it actually results into a new stage, which involves shuffling. Okay. So now the data is joined. After joining, definitely you have to focus on further aggregations. Okay. Typically, join follows map. If you want to do further transformations such as aggregations, etc. Why the map? Now you have order ID, you have order date, and you have order revenue. From this, if you just want to get revenue for each day, you don't need order ID. You can discard this. Okay. And for that, you can use the map function and all those things. I will not cover that at this time. We will see that when while as part of developing the end-to-end complete application, I will connect all the dots. But for now, I will show a simple example of what we will be doing using map functions. Okay. So here, this is nothing but a tuple. So let us create a tuple which have a nested tuple, a simple Scala structure, not a Spark structure, and try to understand what kind of functionalities we can perform on the tuple. Okay, so this is how you can actually create a sample tuple. String has to be enclosed in double quotes. Now you can see T is of type tuple. The first field is of type integer. Second field is of type tuple, which have string and double in it. All these are paired tuples. Now, if I want to read only the order ID, what I can do? I can just say t dot underscore 1, which will give the order ID. So these are tuple operations which I have covered as part of the Scala also. Now, if I want to get this nested tuple as is, I just have to say t dot underscore 2. It will result in a tuple. Now, if I want to get date from this, what I can do? T dot underscore 2 dot underscore 1 will give us the date. And if we say t dot underscore 2 dot underscore 2, it will give the revenue from that, the second element in the nested tuple. Okay. Now, if you want to extract the date and order item subtotal so that you can actually aggregate at the date level, you just have to say, okay, again it is frozen. No, I think Venu, it's only for you. It is not frozen. I think it's not only with internet. I think even WebEx have some issues for past few days. Yeah, it is not frozen. If apart from Venu, is it frozen to anyone else? Because my colleague or my friend, for him it is normal. Yeah. So Venu, you can reconnect if it is still frozen. Okay. So orders join dot map. So in this case, I just want to get date and order revenue, and after that, I want to aggregate at the date level. So I can say underscore dot underscore 2, which means I am reading the second element from the tuple. That's it. Or I can also say rec implies rec on dot underscore 2. So this underscore is for parameters without using parameters without naming them, without explicitly naming them. But it has limitations I have covered as part of the Scala also. So I will not be getting into too many details here. I typically don't prefer taking this route because there are certain limitations and there is no need to remember those things. And naming it makes a lot more sense. For example, if you are trying to process orders, if you can name the record as order, it makes some sense. Your code will be manageable over a period of time. Okay, now you can use this rec implies rec dot underscore 2 and then take off 10 dot for each println and hit enter. Now you see these are nothing but tuples. Once they are tuples, you can use reduce by key or aggregate by key to add this sort item subtotal at each date level. Okay, we will see that again once we complete all the transformations. Any questions here? It's where join is one of the most important transformation. We'll be using that whenever we talk about more than one data sets. Okay, so now let us see the left outer join. Before that, let us understand our data. I didn't get order join part. What didn't you get? You can unmute and you can let me know where the confusion is so that I can respond to you. Hello, Ashish. You mean this one? Okay, I understand. The statement what I have made earlier regarding order is, for example, if you want to use map function on some orders data or even orders join data, okay, either you can, and you want to extract only date and order item subtotal. So initially orders join have the order ID and then a tuple which have date and order item subtotal. Let's say our requirement, our business requirement is to get the revenue for each day. If you want to compute revenue for each day, you don't need order ID anymore. you can discard it. For that, what you have to do for each input record, you just have to discard the order ID. So you can use map. Is it clear till here? Why map? Why I am using map? Okay. Now you use map, and I want to get this one. It is part of a tuple and it's a second element. So how I will do? I will use like this. T dot underscore to T. I have created a tuple, copying this one. Okay. So T dot underscore to gives date and order item subtotal from the tuple I have created. Now I am applying that same logic as part of the map function to get this one. And then as part of that process, I mentioned that either you can name your parameter such as rec, implies rec dot underscore 2 to get this portion, or you can also use underscore to represent the parameter in simple cases. It will not work all the times. We have seen that as part of the Scala also. So personally, what I made, the statement I made was, personally, I don't prefer using underscore. I prefer to give more readable name. For example, if I am applying map function on orders dataset, the name of the parameter can be order because each element is nothing but an order. That's why I name it more appropriately so that code will be manageable over a period of time. That's the statement I have made. Is it clear? Yeah. So now we have to see the outer join. So when it comes to join, as long as there is a matching key in both the datasets, you will get the record. And now, before getting into the left outer join, let also get the counts of each of the datasets we have joined, and also the join results. So if you say orders.count, there are 68,883 records. And if you say order items.count, there are 172,198 records. Okay. And if you say orders join.count, it also returns 172,198 because in order item you have observed that order ID is duplicate. There are multiple items for each and every order. Okay. And order item order ID is a mandatory field in order items. Hence, whatever number of records you get in order items, after joining also you will get the same number of results. Okay. Now let us get into a bit detail with respect to data. Okay. We have orders dot take of 10 dot for each println, and you can see order ID is a primary key field, and then date. That's why you got 68,883 order IDs overall. But when it comes to order items, first we will validate how many order IDs present in order items. Because for a given order, there can be a scenario where there are no order items. For example, you went to the, you log into Amazon and you add products into the cart. And Amazon will actually maintain the state of the cart for some time, and you delete the items from the cart. So at some point there can be empty cart also. Then you might have canceled the order after removing the order items. You might have canceled the order. That might result in a order where there are no order items. So for left order join, we will take that use case. We will try to identify those orders where there are no corresponding order items. Okay. So for that, first we need to review the data and see whether our assumption is correct or not. Whether there are order items, whether there are orders without order items, without corresponding order items. How can we validate? We have order items data set, and if you do take of 10 dot for each println, you get the order ID at the first field. Okay. So what you can do is you can say order items dot map, and then you can say rec implies order item implies order item dot underscore 1. So we are extracting only the order ID, and then I can say distinct Distinct is another operator or API within Spark, which you can apply on RDD, which will give us the distinct elements. And then we can do the count. You can see there are only 57,431. Excuse me. Which means that there are only 57,431 orders where there are corresponding order items. Rest of the 11,000 odd orders does not have entries in the order items. So for that reason, as a business guy, I want to see how many orders that are either cancelled or closed or completed or in processing, etc., where there are no corresponding order items. In that case, what we have to do, we have to left outer join orders with order items, or we have to perform outer join between orders and order items. Okay. So now I am saying val. So instead of just taking order item subtotal, this time, sorry, date and order item subtotal, this time I will take the entire record for both the data sets. Okay. So I'm copying these two things, and if you we'll get into that. First, let me create these tuples. And if you look at the tuples, both orders and order items have two elements in them. The first one is same, it's order ID in both. This time, the second element, I am getting the entire record. Okay, so this string means the entire record. And if I do join, again, I'm doing normal join. Okay, and if I try to preview the data, thank you. Just give me a moment, I am drinking some water. Okay, now you see orders join have the order ID as key, and the value is the data from both the data sets. So the first four fields are from orders, and the next 6 fields are from order items. Because our data is also comma separated, and also the elements in the tuples are comma separated, you see results like this, and it can be a bit confusing. But if you just apply the map function, and say spec dot underscore 1, then spec dot underscore 2 dot underscore 1. I don't want to have it as tuple. And then if I give a different delimiter like column, spec dot 2 underscore 2 dot underscore 2. So I'm converting it up, the tuple into string to give the proper demarcation between orders record and order items record in the value of the main tuple after joining the results. Now you can see up to here it is orders, and this one it's from order items. Okay, this is for typical join. Now comes outer join. So outer join means if you say I want to perform an outer join between two data sets, either you have to perform a left outer join or right outer join. All three means same. Left outer join, right outer join, and outer join is same. It's only mentioning about the position of the data set. So in this case, if I say orders left outer join val orders left outer join equal to, if I want to use left outer join API, whatever data set from which you whatever data set you consider as a superset has to be on the left. If you are performing a right outer join, whatever data set you are considering as a superset, you have to put it on the right. In this case, we are talking about order ID, and orders is the superset and order items is the subset. Okay, because we are performing the left outer join, we have to put the data set which is considered to be superset, which is orders in this case. Orders dot left outer join and then order items and hit enter. Okay, and now you can actually do the count on orders left outer join dot count. You got 183,650. How many records we have in order items? We have only 172,198. But now we got 183,650 because there are certain orders which does not have the matching record in order items. Those are also added to this new data set. Okay, and we can preview the data. Orders left outer join dot takeoff 100 dot for each println and hit enter. You can see that some of the records does not have the corresponding element from the order items. Okay, so if you want to get this only these records where there are no corresponding items in order items, what you have to do is, after joining, you have to apply filter, because you want to discard the records which are existing in order items as well. We are interested only in those orders where there is no corresponding order item. Okay, so our filter criteria have to say that filter out those records which have some value in it, and only consider those things which have none. Okay, and then you can say rec implies rec dot underscore 2 dot underscore 2 equal to none. I hope this will work. Let us see. Yes, it is working. Okay, but I'm interested only the ones where there is no corresponding order item, which means rec dot underscore 2 dot underscore 2 has to be equal to none. And then I can say takeoff 10 dot for each print ln. And you can see you only get the data where there is no corresponding order item, and you can also do the count. There are 11,452 records. Okay, so that is how you can use outer join. And left outer or right outer is only positional. It's not, there is no significant meaning to it. Outer join is the important concept. Okay, now if you want to do the right outer join, for example, in some cases, there can be two data sets where there is no one-to-many relationship. In that case, you might want to do right outer join also. Let's say orders and order items are the two data sets where there is no primary key foreign key relationship. Okay, so I want to see all the orders where there are no corresponding order items, and also I want to see all the order items where there are no corresponding orders. In that case, it makes more sense to put order items on the right side and perform the right outer join. Okay, so let us see orders right outer join equal to orders dot right outer join order items. You can also say left outer join, but order items have to be here and orders have to be here. So it's on. So whatever table you consider to be the superset, or whatever data set you consider to be the superset, determines what type of, the position of that determines what type of join, outer join you are performing. If the superset is on the left, you have to use right outer join. If the superset is supposed to be on right, you have to use the right outer join. That's it. Okay. And now we actually perform the right outer join, and let us see if there are any none records. Now you can see in the resultant RDD. Okay, let's preview the data. Dot take of 10 for each println and hit enter. Okay, so here you can see uh, uh, when you perform the right outer join, the first element came from orders and it was sum here. It is sum here. Similarly, when I ran it in the past for the left outer join, because order items which is on the right side is subset, you got the right portion of the second element in the tuple as sum or none for if the corresponding record does not exist. Even in this case, if the corresponding order does not exist, you will see none here. Okay, so now let us try to see if there are any orders, sorry, any order items where there is no corresponding order. What we are supposed to do, we have to use filter. Okay, and as part of the filter, we have to say rect dot underscore 2 dot underscore 1 equal to none. And then you can say take of 10 dot for each println. It should not return any record because we have one-to-many relationship between orders and order items, and orders order ID is the superset of order items order ID. So this should not return anything. And you can see there are no records, which means there are no order items where there is no corresponding order ID, which is correct. Okay, so this is left outer join and right outer join. Both means same. It all depends upon where your superset is placed. If it is on the left side, it is left outer join. If it is on the right side, it is right outer join. And then next thing is full outer join. Full outer join is nothing but a left outer join union right outer join. Some cases again, if you take the tape, if you take two data sets where there is no formal one-to-many relationship, then if you want to get all the records from first data set and all the records from the second data set, if they are matching, we will get as one record. If they are not matching, you will see the sum on the left side. Sorry, let me do it and then I will explain. So here I am saying orders full outer join, okay, equal to orders dot full outer join order items and hit enter, and then let us preview the data. So you can see in this case now both are sum, because there can be scenarios where there are records in the first data set, and also there can be scenarios where there are records only in the second data set. In that case, the first data set will have sum, and the second means if there are records in the first data set but no corresponding record in the second data set, the first element in the tuple will be sum and the second element will be none. Similarly, if there are records only in the second data set but there is no corresponding data set in the first data set, then the first element in the tuple will be none and the second element will be sum. Okay, so full outer join is nothing but left outer join union right outer join. That's it. You have to put both the data sets in the same position. So orders left outer join order items union orders right outer join order items is orders full outer join order items. Okay, so that is about the typical join operations. Any questions here? And these concepts are important even when we talk about SQL. We perform filters by using where condition. We perform aggregations by using group by clause, and then using some functions like sum, average, etc. We perform join operations using join operator. we do left outer join, right outer join, all those things even in SQL. Okay. So now let us see the next um, thing, which is called as co-grouped. Okay. And also we have Cartesian. Cartesian is pretty straightforward. So for each and every record, it will try to Cartesian for each and every record in the first data set, it will try to map to the each and every record in the second data set. So instead of using RDDs from our data sets such as orders and order items, I try to use simple collections and parallelize as part of this example. So uh, there are two variables A and B, which are nothing but RDDs. One is of type RDD of integer, A is of type RDD of integer, B is of type RDD of string. And when we do Cartesian, let us see what will happen. Okay, and then A dot Cartesian of B dot collect dot for each println. So what will happen is one Cartesian B is 1 comma hello 1 comma world. Two Cartesian B is 2 comma hello 2 comma world. Three Cartesian B is 3 comma hello 3 comma world. Okay, so the number of elements will be number of elements in the first data set multiplied by number of elements in the second data set, which is 8 in this case. Okay, so this is about Cartesian. And now co-group. Cartesian is pretty straightforward to understand. For co-group, let me run this command first, and let me preview the data. I do not remember on top of my head. I think once I preview the data, I will be able to explain. Just give me a moment. So Ashish is asking where Cartesian is used. So typically, we use one of the use cases. I think matrix related stuff, matrix multiplication kind of stuff. We use Cartesian product. Okay, and and also yes, if you want to get the affinity, for example, you have if you take a e-commerce platform, you have different types of categories. You have electronics, you have furniture, you have many other things. Okay, so most of the times, certain set of electronics has to go with certain set of furniture. A TV can go with a TV stand, a kind of a stand, not just TV stand, or a wall mount. Let's say wall mount. A TV will go with a wall mount. Not that one. Not that is not the correct example. So let's look at the higher level categories. We have furniture and we have TV. Sorry, we have electronics. And there is no one-to-one mapping or one-to-many mapping or many-to-one mapping within furniture and electronics. The relationship is many-to-many. Okay, most of the time we have to create the Cartesian product of these two things, and we have to do additional processing to identify which electronics go with what kind of furniture. Okay, so in that kind of things where there is no formal one-to-many or many-to-one relationship, if you want to process the data in with on those products by joining those two data sets, most likely it will result in a Cartesian product. But as part of the Cartesian product, we will also do further processing. After that, our final result will be small. But in the middle, we have to do the Cartesian product. Cartesian product is one of the pain point in many applications when you try to come up with matching products uh, by matching data sets where there is no formal one-to-many or many-to-one relationship. Okay, we typically end up in Cartesian product in many such cases. So Balamurli, I think Balamurli is responding to Ashish's question. We have transaction tables and offers table. Yeah, that is another example. Balamurli. So Cartesian is a side effect of this mapping. Cartesian does not mean mapping. Cartesian is the side effect of the mapping. If you have to get that mapping, you have to do the Cartesian product first. Yeah, distance between multiple cities. Yeah, it's a classic example, Srikanth. Or not only distance. For example, if you want to go from point A to point B, there can be n number of ways to go. Okay, and first you need to identify what are the different ways there are. By applying additional criteria that you should not, you don't want to uh, go beyond 10 miles from point A to point B, and if you want to get all the appropriate, all the ways to go from point A to point B, you will get only n number of uh, uh, different paths. If you don't put that additional condition of 10 miles from point A to point B, there can be infinite number of paths, and that is Cartesian product. All the ways to go from point A to point B is kind of Cartesian product. But when you try to process data using Cartesian product, you have to apply additional conditions such as, okay, give me only those paths which are less than 10 miles between point A to point B. Okay, that additional criteria is very important to get the uh, results accurate, more appropriately, and performance is also good. Okay, now let us talk about co-group. Okay, let me see. Let me see the. This also did not give any idea. Let me read it here. Yeah. So when it comes to join, right, the result will be like this. Whereas when it comes to co-group, the result will be like this: k comma I double v of I double w. Okay. So all the elements matching the uh, first, all the elements in the first data set will be one list matching the key, and all the elements which from the second data set matching the key will be another list. That's why you can see the results are compact buffer in the tuple. Okay, so that's the difference between co-group and join. When it comes to join, it will actually flatten out all the records, and you can see 172,198 records. Now, if I do co-group, it will only give 68, not even 68,882 records. It got disconnected for some reason. So while it is joining, let me make the announcement for YouTube folks. People who are on YouTube, if you like the content, make sure you click on the like button. That means a lot for us. If you need environment to practice, you can go to lab.itversity.com and you can enroll for our lab. If you have any questions while practicing, you can definitely post the questions on discuss.itversity.com. I'm not sure who this guy is. He just comes and dislikes almost every day. I don't know why he is doing that, but at least if you don't like, it will be good if you can provide the feedback in the chat or the comment section, so that I can take care of that feedback and improvise on the content. Just disliking for no reason doesn't make any sense. Okay. Even those who are liking it also, if you can actually give the inputs to improvise the content, I'll be glad to work on that aspect. Meanwhile, it is launched, and let me first do the join once again. For that, I need to have the path variable. Unfortunately, YouTube will not tell who is liking or who is disliking. At least I can follow up with him personally to get some feedback. Okay, now if I do orders join dot count, it has given 172,198 records. We have seen earlier also. Now if I do co-group, and if I say orders co-group dot count, it actually returns 68,883, which is from orders. Okay, so for each order ID, because we are getting a collection, your order ID will become unique when you do co-group, and your elements will be collection, two collections, one for each data set on which we perform the join. That being said, we are done with joining the data sets, and we will actually go ahead for the set operations, which is distinct, union, and intersect. Before getting into set operations, a lot of guys think joins and sets are same, but that is not the case. In case of join, only the key is the common factor. The records, the values can be anything. Whereas in set, both the data sets have to exhibit the same behavior. Okay, you cannot perform union, intersect, or difference by on a set which is having numeric elements, and on a set where there are strings in them. Those two are not uh, they cannot be you cannot perform a union operation on those two and get a set of numbers or set of strings. That is not possible. Okay, so it is to perform set operations, both the data sets have to exhibit the same behavior. Okay, and when it comes to union, it will get all the elements from both the data sets. When it comes to intersect, it will only get the common elements in both the data sets, and distinct will get all the distinct elements in a data set. Okay, in when it comes to union, it will not get the distinct elements when you perform set operation set union in Spark. It will have duplicates. If you want to eliminate the duplicates, you have to use distinct. Whereas in Scala, set itself is a trait, and if you define a uh, particular collection as a set, it will eliminate the duplicates by itself. But here we are dealing with RDD. RDD is never a set. For that reason, if you want to union two RDDs and then get distinct elements, you have to perform union on both the data sets, and then you have to perform distinct to get the distinct elements. Okay. Diff and complement are not available on top of RDDs. Probably you might have to do left outer join, and you might be able to get diff or complement. But within set operations, they provide only three APIs: union, intersect, and distinct. Okay. Now let us define a problem statement, and then let us try to use these operations to get the results. Okay. So let us see. The problem statement is, let us see what are all the distinct order item product IDs sold in a given month. Okay, so there is a question. Yeah, it will be different. Uh, you cannot say orders join dot count dot distinct. You have to say orders dot map. Okay, so you have to say orders join dot map, and then get the first element, which is order ID, and then distinct, and then count. Then it gives 57,431 records. Yeah, and orders co-group got 68,883. The reason is, if you look at the co-group, right? Orders co-group, dot take of 100 dot for each println. Okay, you can see, um, you can observe this record. What is happening? There is a already called 34,268. Obviously, there will be a record in orders, but there is no corresponding record in order items. Okay, so co-group, when you try to, okay, is it stuck? Okay, let's wait for a moment. Yeah, I'm waiting. Now it is back. Okay, so when you try to compare the count between co-group and join, you have to do the left outer join, not join directly, because join will only get those order IDs which is present in both orders and order items. But when you do the co-group, it need not be the case. Even if one of the dataset have the record, you will have an entry in the RDD which is result of co-group, like this one. This one will never come as part of join. But if you do the left outer join, okay, let me say orders dot left outer join order items. Okay, first let us do the count. It returned 183,650, and then apply map and get the order ID, and then count, and then distinct, and then count, and you will get 68,883. Okay, so this is how it works. You are not actually comparing the the results of orders join and orders co-group, join and co-group in a correct manner. Okay, so now let us go back to the set operations. So the problem statement says, I want to get all the common products sold in the month of December 2013 and 2014. Let us see what are all distinct order item product items sold in a given month. But the month is not available in order items. Hence, we need to join with orders to get month, right? And then we have to identify, we have to filter only for those products which are sold in December 2013 and then sold in January 2014, and I want to get the common products between the two. So I can apply intersection. If I want to get all the products sold between the 2 months, I can use union. Okay, so here you can see first I am actually applying the filter on orders to get the data from 2013 December. Okay, you can see it here, orders 2013 12 dot take of 10 for each println. You can see the data here. We have order ID and the date. Using this information, now if I join, I will only get the details from order items which are sold in 2013 December. Others will be discarded. So for that, I am actually getting the order ID from order items and then order item subtotal. For just for the heck of it, I am also getting order item subtotal. Now I can join these two, orders and order items. Before joining, let us do the count. Dot count and also order items dot count. It returns 172,188. But now when we join, we are only getting the order items related to 5,892. So the number of records will be lesser. Okay, so if you want to get the distinct products that are sold in December 2012, we can join orders 2013-12 with order items, and then okay, let me first apply this functionality. Orders 2013-12 dot join order items dot take of 10 dot for each println. Okay, and you can see this is order ID, this is the date, this is the product, and I want to get all the distinct product IDs which are sold in December 2012. Already the data is belongs to December 2012 only. That's why I have applied the map function to extract this one. Order underscore 2 dot underscore 2 will give this one. I hope everyone is clear on this. If not, I will explain. And then dot map function will only create the collection of these product IDs, and then distinct will actually get the distinct orders. Now you can actually see the count. But let us see the results. You got products that are product IDs that are sold in December 2012. You can get the count. There are 99 products which are sold in December 2012. And then let us see the products which are sold in January 2014. Sorry, it's December 2013 earlier. It's now January 2014. Okay, applied the same logic. Only thing is the filter condition changed to 2014 01. And then, okay, let's wait. It got struck. It was stuck. I don't know for some reason. Then it is taking a little bit more time. Yeah, now it came back. And now you can get the products which are sold in 2014 January. If you want to apply distinct, you can say products 2014 01 or distinct. Okay, again it got stuck. So let's wait a moment. Even for 2014 January, the count is 99 only. Yeah. Okay, now it is back to normal. Now let us see what are the common products which are sold between the two. I have to create this one also. This is for products 2013 December, and this is for products 2014 January. So if I want to get the common products which are sold in both the months, I can just say products dot intersect or intersection for products 2013 December intersection products 2014 01 dot take off 10 dot for each println and hit enter, and you can see a few products which are sold in both, and then you can get the count. There are 98 records, 98 products which are common, which are sold in both the months. Now if I want to get union of these things, I just have to say union here. And as I have mentioned to you earlier, union does not eliminate the duplicates. That's why you see 29,395 records. If I want to get the distinct records, I just have to use distinct here. Dot count, and you can see 100. Okay, so out of 99 products which are sold in 2013 December and 2014 January, 98 products are sold in both the months. Only one product, a different product is sold in December 2013, and a different product is sold in 2014 January. So this is how you can perform the union operations and get the insights in your data. Probably, if you want, you can actually test at a day level rather than month level. There can be some differences, considerable differences between the products which are sold on one day versus the products which are sold on other day. Okay. So that's it about set operations. Very simple to understand as long as you have basic mathematics understanding. There is nothing fancy here. Only criteria which you need to keep in mind is both the datasets have to exhibit similar behavior. Okay, if they are different, then they are not. They are two different sets which cannot be clubbed together. It's as simple as that. Okay, now get into sorting and ranking. And as part of this, we will be seeing sort by key and group by key. I will just cover theory part of, for today as much as I can till 10. And then we will actually get into more details as part of the next class. Okay. So sorting is typically done by sort by key and more complex. Hmm? Again, it got stuck. Okay. Yeah, now it is back to normal. Sorting is typically done by sort by key, and more complex sorting as well as ranking is typically done by group by key. So group by key is very, very powerful and sophisticated API. Apart from aggregation, group by key comes handy in many other transformations. Even in aggregation, sometimes we might have to use group by key rather than using reduce by key or aggregate by key. So group by key is very, very, very important transformation. Need not be for the certification purpose, but on uh, on implementing projects, you need to have a very good handle on group by key. Group by key itself is very simple, but after group by key, you should be able to determine whether you have to use map or flat map, and how to process the collections which are created because of the group by key is the main thing. And for that, you need to understand the APIs related to collection of the underlying programming language. If it is Scala, you need to be strong in Scala collections. If it is Python, you need to be strong in Python collections. If it is Java, you need to be strong in Java collections. Okay. And at times, we might have to sort the data by composite keys. In that case, we need to bring all the elements to key. Only then you can actually sort the data based on composite key, which means there can be multiple fields to sort the data. For example, let's take the orders itself as an example. Orders are, yeah, let's take the orders itself as example. Okay. And if you see the syntax of sort by key, like any other by key operation, it also expects the element to be of key values pair. Okay. So you have to transform the data first into a key value pair to apply sort by key. So you have to use map, then only you can use sort by key. And sort by key also result in shuffling. So any by key operation result in shuffling, be it group by key, reduce by key, aggregate by key, join, co-group, now sort by key. Union need not result in uh, shuffling. Okay, it works a bit different way. That you can actually go ahead and look into the Spark UI while you practice on sort of union operations and see the behavior, how it is behaving. Okay, so now if I want to sort the data, let's say by order customer ID. Actually, the input data which we are using is already sorted by order ID. Instead of ordering by order ID, if I want to sort by customer ID, okay, so that will become the key. So when you apply the transformation to convert your record into key value pair, whatever field you want to, whatever field using which you want to sort the data, you have to transform your record into key value pair using that as key. In this case, order customer ID will be the key, and value can be anything. Let's take the complete record as value. Okay, so what I can do, orders dot map rec implies rec dot split I have to use circular brackets here because we have to create a tuple. And then we can say 2 to get the customer ID. It is of type integer, so I'm saying 2 int. It is very, very important. If you don't change it to integer, then you will, there will be functional issues also. Data will not be sorted in numerical order. Data will be sorted in string order, and the behavior will be different if you sort the data uh, in numerical order using numbers versus the alphabetical order using numbers. There is a difference in the functionality. You need to understand that. Very, very, very important. And then let us get the entire data for each record. And I'm using rec. And then I'm saying sort by key. Let us first preview the data. Take off 10 for each int ln. You see, this is the key and this is the value. Comma is a bit confusing here because we are using the same delimiter that is being used for the tuple, but as we know the data structure, we can easily figure it out. Okay. And now if I just say sort by key, data will be globally sorted. I have to use circular brackets. And I can say take off 100 for each int ln. And you can see data is actually sorted by the customer ID. Okay, here key is customer ID itself. That's why even the first field it is showing one same as the customer ID. If you want to discard that while printing, you can apply the map function after sort by key and only get the records. By saying red dot underscore 2 and hit enter. Now you see data is similar to what we passed as input, but it's sorted by order customer ID. Now if I want to sort the data based on order customer ID and then order status, it's a sorting by composite key. Okay, so how I can do that? I just have to create this key as tuple, which contain both, yes, tree, that is correct, which contains both order customer ID and then order status and hit enter. Now you see you got the completed orders first and then on hold and then pending payment. Okay, so this is how you can actually use sort by key to globally sort the data either by one key or composite keys. What is that? Okay, so that being said, let me know if you have any questions. We'll wrap up for today. Unless you have any questions, I will take few questions. You can ask anything. Yeah, uh, good that you reminded now itself. If you want to do it in descending order, you can say false here, and it will sort the data in descending order. Only ascending and descending can be controlled. And also, when you say descending, it will be descending on both the fields. For example, if you want to say ascending on one and descending on the other one, it is not very straightforward. Okay, for example, let's say I want to sort the data based on ascending order by order status and then descending order by order customer ID. That we can achieve just by saying this rec dot split comma 2 dot to int. Because it is of type integer, we can negate this. Okay. Well, then we will get ascending order by order status and then descending order by order customer ID. But if we have to do the other way around, if I want to get ascending order by order customer ID and descending order by order status, it is not that straightforward because we cannot negate a string. Okay, in those scenarios, we have to use group by key and come up with more complex logic. Okay, so now you can see you got all the cancelled orders first, which is in descending order by order customer ID. Let us see 1,000 of them to see after cancelled we get the completed orders. Even 1,000 we have cancelled orders, but we'll get it in. We will get the results as expected. Again, it seems to be stuck. So yeah, I will take few questions. We will continue on sorting as part of the next class. So we even if I extend for 2-3 classes, I will not be able to cover Kafka, Flume, and Spark streaming. But I have a good material online. You can actually go through it, and if you have any questions, I will let you know. But I will cover Core Spark and data frames and Spark SQL in detail. Okay. Any other questions? You can ask anything, whether it respect to your career or other technologies. So I will wait for probably 20-30 seconds and I will stop the session for today if there are no questions. That's what, Ashish. I will not be covering streaming as part of this course because of the time constraint. I'm not sure about Lambda. I haven't touched Lambda yet, but let me show you. I will troubleshoot your issue, Amar. Just give me a moment. So if you go back to my previous courses, let's say CCS Spark and Hadoop Developer, okay, you can see the streaming related information along with Flume and Kafka. So you can actually follow these things. If you have time before we end the course, you can follow these things. And if you have any questions, I will be glad to answer in this last 10 minutes after the session is done. So 15, 16, 17 are the videos which you should follow. Okay, again it got stuck. Yeah, now it is back. So I sent the link. Let me send it to the YouTube folks also. Okay, so let me take these questions one after the other. First one, Amal, you need to give your login ID. I'm not sure about running streaming jobs concurrently. You go through that material and let me know if you have any questions. Okay, so let me troubleshoot these issues. labs.itversity.com users. It's working. Most likely you might be pasting incorrectly. You have to use shift insert if you are using Windows. If you are using Mac or Linux, you have to use on Mac you have to use Command V. On Linux you have to use shift insert.
So after clicking the key, I have to press shift enter.
Yeah. So this is how you will do. Copy the username, and when you select that one, right, your console might get faded. You can see it's empty rectangle now. So first you have to click so that it is bold like this. And when you paste, then only it will paste. Even for the password, you have to do the same thing. Once you copy the password, you have to first click and then use Command B or Shift Insert to paste. Then it will work.
Shift Insert in Windows?
Yeah, Shift Insert in Windows. Control V will not work. So this UI does not understand Control V. That's why it will not work.
Okay.
Okay. Yeah, you can give a try. If you still have any issue, you write it on discuss.itbursty.com. Someone will do a team viewer with you, and we will make sure the issue is closed. Okay. So Somalia is asking, will there be some sample questions in? Okay, let me go one after the other. So next question is, Dheeraj is asking, do you cover Spark with Python? Again, if I have to cover with Python, I have to spend enough time on Python and all those things. But as I have mentioned, if you go to my work in progress website, which is available to everyone, but don't go to it at this time. And if you go to the courses, there are many courses which are in draft state. Okay, and one of the course which we are focusing on, which will be creating a self-paced course at the least, is Learn Python for Spark. Once that is done, I will also create Spark related content so that anyone who is following Python can actually complete this course and learn Spark with using Python as programming language. It will take time though, because there are so many things which are going in parallel. So Venkatesh is asking on GW02 in remote desktop, where can I see exam simulator? So let me first again show you how to connect to the remote desktop. You have to use VNC viewer or some other tool like that. And then you have to give your port number, IP address, and also you have to enter paste the password. Once you paste the password, you will get to the environment like this.
Sorry to interrupt. Then how did you add the remote desktop like GW02?
In VNC viewer, you just have to say file, new connection. That's it. Give the IP address, which is gw02.itversity.com, and then your port number. Your port number, you have to log in and get the port number.
So here we don't give any username and password?
No, you don't need to give the username and password. We have taken care of from the back end. You have to give the password though, not the username. So let me show you. So here, I am connecting to GW02. Let me pull this aside. Okay. And you have to run this ps-ef grep-i-vnc. Okay. And you will see a process with capital X VNC, and you will see the number here. It's an index. You have to add this to 5900. Okay. And then you can come here, give 5901. If it is 100 for you, you have to make it 6000. If it is 110, it will be 6010, something like that. And then click on OK. And then double click. It will prompt you for the password. You have to use your lab password. Paste it here. You can click on remember password and click on OK. You don't need to enter password again and again. Then you will end up here. So now for now we only provide Chrome and Sublime Text, etc. We are working on creating the questions, and we will be providing that by the end of this month. For now, what you can do is you go to terminal, okay, and whatever. So you are already on the gateway node. Whatever I am doing, right, you can actually use this one also and actually start Spark shell using this terminal. Okay, it got stuck. So wait for a moment. So even though questions are not ready yet, still you should be able to get acclimated with the environment so that you can go ahead and give the certification with confidence. Okay, questions is one thing. Questions, whatever I am explaining, questions will come in the same format. But the main challenge which I have heard from the people, more than questions, they are not familiar with this remote desktop on CentOS, how to access certain tools and etc. So, for example, if you want to run Spark Shell, okay, you have to open terminal, and the way you can open terminal is by going to applications, and it might show up here, it might not show up here. So you should know where the terminal actually resides. It can be in utilities. This is the main location. Favorites, if you are frequently using, it will be loaded into favorites, otherwise it might not. Okay, so you go to utilities and click on terminal, and it will launch the terminal. So once you launch the terminal, this is how they will provide the environment to you. The machine which you will be accessing will be acting as a gateway node for the cluster. So from here, you can run Hadoop ss-ls command to run HDFS commands. You can do Spark Shell master yarn fonts spark.ui.port equal to enter, and it will launch the Spark Shell, and you can start writing the code. Okay, and also you can use Sublime Text, gedit, etc. So all those features which will be provided to you as part of this remote desktop to execute the programs is already available. Only thing missing is questions, but questions is not a big deal because you will be practicing this using similar questions even on the even by logging in to the by logging into the cluster through a web console or PuTTY or Linux or Mac terminal. It's the same thing. Only thing is when you go to the certification, you need to be familiar with this remote desktop. That is already taken care. Okay, so then Somalia is yeah. I think I have answered Somalia's question. I will be coming up with questions very soon. Balas is already done. So she is asking, do you have any course plan for advanced Spark? This is advanced. So core Spark, if you go to any typical course, as part of the basic course, they cover word count. Okay, they even does not cover these joins and all those things from the real world perspective. So whatever I am covering is kind of advanced Spark. Especially, I will be covering Spark SQL, data frames, and all those things. And also, if you go through the material, which is there as part of this course, okay, after going through transformations and actions, we will see the end-to-end life cycle of the project, development as well as execution. And also, there is a more Spark concepts and core APIs. With respect to core APIs, I will be covering map partitions, accumulators, broadcast variables, and all those things. So this is almost advanced Spark. Only thing that will not be covered is MLlib and graphics. Those are modules. It's not advanced Spark, core Spark, etc. Those are modules, and I will not be covering ML at this time. Probably in future, I'm in talks with a guy who is a data scientist, and we both might team up together and come up with some content on ML. But as part of the course, we will not be focusing on that. Rather, we will be focusing on the other skills that are relevant for the big data engineer. You will be seeing the content on Scoop, Hive, integrating Spark with Cassandra, which is a NoSQL. That kind of stuff we'll be focusing on for the students especially. I'm not sure, Sri, whether you are a student or experienced professional, but keeping students in mind, by the time they come out of college, rather than breaking their head on ML and graphics, they should focus on the Hive, which is Spark SQL, which is SQL, which includes Spark SQL also, Cassandra, which is a NoSQL database, integration of Cassandra with Spark and Scala, which is a programming language and a distributed computing framework. Those things will be covered for the students who will be passing out by 2019. We will come up with the content with all those things. Even we have Cassandra cluster as part of the lab, which is accessible from the gateway node. Okay. So that being said, that's it for today, and catch up with you on Monday. Have a nice weekend.
Hey, Durga,
Yes.
this is Anna. So you said you have some SQL videos.
I have some.
SQL videos.
Yeah, so I have started creating that. I'm not able to spend enough time on that. So this is the playlist. I will cover sooner or later. I will cover SQL in detail.
Okay.
Okay, and the SQL which I will be covering is from Oracle. SQL does not change depending upon the underlying technology. It is almost same. There will be some subtle differences, but if you know SQL, you should be able to work on any database, be it Oracle, be it Informix, be it MySQL, be it Hive, be it Spark SQL. Okay? Yeah.
Yeah. Okay.
Have a nice weekend and catch up with you on Monday. Those who are on YouTube, thank you very much for joining the session. As I always request, if you like the content of the video, please click on the like button. If you want to share with our friends, just click on share and share on the social networking platforms. And please help me spreading the word so that I get enough traction in the learner community. And as I have mentioned to you earlier many times, if you need environment, use labs.itversity.com. If you want to ask any questions, go to discuss.itversity.com and you can raise the questions. And finally, if you are not subscribed to my channel yet, if you end up on this video and if you are not subscribed to my channel yet, please do so. You will get the reminders about my live events, workshops, etc. I will be conducting some workshops in very ad hoc fashion on important topics. So you will at least get the reminder when that events happen if you subscribe to the channel. So please do subscribe to the channel so that you get those reminders. And you can connect with me on any social networking platform. Just search for Durga IT Varsity. You will get the details and you can connect with me on any social networking platform where you are active. That being said, thank you. Bye.